Okay, this is section 14.3. This is called factors affecting solvation or factors affecting how things dissolve in a solution. I'm going to talk about the intermolecular forces that affect solvation, define what solubility is, understand the factors that affect solubility. Exothermic reaction is one that releases chemical energy when the bonds are rearranged. And I'm going to go over these different vocabulary terms. Solvation, heat of solution, what an unsaturated solution is, what a saturated solution is, a supersaturated, and briefly go over what Henry's law is about. The main idea is that factors such as temperature, pressure, and polarity affect the formation of solutions. Okay, the solvation process. A solvation is a process of surrounding solute particles with solvent particles to form a solution. Okay, so the solutes are always in smaller concentrations than the solvent. So what happens, especially in water solutions, that the water particles surround the whatever we're dissolving in that solution. If it's water, we'll show you how that works in a second. And solvation in water is called hydration, right? We did a little lab a while back with, you know, how much water was in a hydrate. That's what this is kind of about. So the attraction between the dipoles of the water molecule, remember water molecules have one end that's positive, the other end that's negative because of the um, irregular, uh, because of the difference in electronegativity between the oxygens and the hydrogens. And when you have an ion in a crystal, they kind of break those crystal ions apart with these dipole attractions. And so this is how it works in dissolving salt. The white ones here are the sodium ions and the green ones are the chlorine ions. Well, the water has these dipole effect. The red end here by the oxygen is negative, so it's attracted to the positive charge on the sodium ion, and the blue part, that's where the hydrogen atoms are, that's going to be slightly negative, so it's attracted to, it's slightly positive, that's going to be attracted to the negative chlorine ion. So there's all these uh, chlorine ions, the chlorine and the sodium ions get surrounded by water, and that's how the solvation process occurs. So it's each one of these gets broken apart from the crystal, solid crystal, to be in solution surrounded by water molecules. Okay, sucrose also dissolves in water, but it does it a different way. Sucrose has all these bonding sites for these OH bonds here at the end of the sucrose, big long, well, relatively long compared to water, the sucrose chains. And so they form these hydrogen bonds with water. And so that's the water completely surrounds these sugar molecules with forming hydrogen bonds with the oxygen and the hydrogen at the end of the sucrose molecules. Oil does not form a solution with water because there's little attraction between the polar molecules, right? So there's nothing for to it. The water doesn't really surround those molecules so much. So the attraction between the oil molecules that still stay put together and the water molecules stay together. So they don't really, this solvation process doesn't happen with oil and water. Okay, so during the solvation, the solute must separate into particles and move apart, which requires energy. And this energy is called, that happens during the formation, the solution formation is called the heat of solution, because when you mix things together, it actually, depending on what you mix, and gives off some heat. The reforming of those, breaking of those bonds in from the solid or whatever we're doing to a um, the solvation process being surrounded by the water will give off some heat. Factors that affect solvation, we know if we want to stir or shake something, like you put your sugar in the iced tea and it doesn't, you want it to, it'll just sit there at the bottom and maybe it'll eventually dissolve, but if you wanted to get it moving, the dissolving process moving more quickly, you're going to stir it up, shake it up, move it around, So the breaking the solution into small pieces increases the surface area. If you take a sugar cube and you grind it up, it'll dissolve more quickly than just putting the sugar cube in there by itself. And if you put it into hot water, the sugar will dissolve quicker into hot water than it will into iced tea. So temperature, all these factors increase the effects of solvation. Solubility depends on the nature of the solute and the solvent. The general um, thing is that likes dissolve likes, polars dissolve polars, nonpolars dissolve in nonpolars. Okay. Unsaturated solutions contain less dissolved solute for a given temperature and pressure than a saturated solution. So you can see in an unsaturated solution you can still dissolve a little more stuff in there. In a saturated solution, that's the maximum amount of solute you can dissolve in a at a specific temperature and pressure. If you put more solute in there, it won't dissolve. It just settles out to the bottom usually. So you can put like salt in water. You can only put so much in there. It's not all going to dissolve. And if you put too much in, the rest of the salt will just sit at the bottom of the glass or jar or whatever you're just trying to dissolve it in. And solubility is affected by the temperature of the solvent because kinetic energy increases the energy of the particles. So this is a little chart. It shows for most things that if you increase the temperature, the solubility goes up. So all these go up a little bit, but you notice that sodium chloride doesn't really, temperature doesn't really affect that one very much. Pretty flat curve. And this one down here, I forget what that element's called, that actually when temperature goes up, the solubility goes down. Okay, so that's the exception. But most of them, as they go up, temperature goes up, solubility increases. A supersaturated solution contains more dissolved solute than a saturated solution at the same temperature. So to get that, you have to heat up a saturated solution so that liquid has, a good saturated amount of solute in it, and then slowly cool it. And as it cools slowly, sometimes it will cool and be like oversaturated. It'll still be in solution, but it's unstable. If you put any little, like if you hit it or you put the jar down too quickly, it will, that extra solute that's in solution will quickly come out of solution. So hopefully I'll show you a little demo on that. This chart's in your book, the solubilities of solutes in water at various temperatures. So this is just kind of a reference thing. Gases are less soluble in liquid solvents at high temperatures. That's because the gases want to expand, right? Gases expand a lot, so they're not going to stay in solution when the gases expand. So that's why if you open up a hot soda, it will more bubbles come out of that than if you open up a cold soda, hardly any will come out. Okay, so and it's under pressure, right? They put the carbon dioxide in the sodas. It's under pressure to make that carbon dioxide dissolve in there, and then when you release the pressure, it bubbles out. That's why it does that, because it's in solution under pressure, and then you release the pressure, then it comes out of solution and it bubbles out, and that's the nice fizzy stuff we like to see in our soft drinks. So Henry's law states that at a given temperature, the solubility given by S of a gas in a liquid is directly proportional to its pressure. So a directly proportional mathematical thing looks like a fraction, right? As one goes up, the other has to go up to keep these fractions equal. Okay, so increase the pressure, you will increase the solubility, right, at the new pressure. So that's just Henry's law. We're not going to do too much with that. Just have to know that vocabulary. That's the end of this slideshow. So answer the questions at the end of on the forum below, and I'll see you guys in class tomorrow.